Hi guys, welcome back. In this episode, I would like to discuss another a string related program. It's called anagrams, a valid anagram. Okay. So what is an anagram? An anagram is a string. It's not about a single string. So anagram can be defined as a two strings S and T. That is S and T are two strings. If S and T are composing of the same characters with a different order, then we can say both of them are anagrams. I don't think the definition was clear. Let us say you have rat, RAT, and you have art. So you can observe that both these strings, rat and art, are made up of the same characters, which is A, R, and T. But they are not the same strings because they are arranged in a different way. So if any two strings will are gonna have this property that they are made up of the same characters, then we can say that those two strings are anagrams of each other. Okay, let's look at an example that includes anagram itself, because anagram can also be an anagram. So what is so let's take another example. Okay, another string called Nagaram. So is anagram and Nagaram, are these two anagrams? If you observe closely, we have N, we have A, we have G, A, and we have R, A, M. So these two are anagrams. But how can I prove that? So how can I prove that using an algorithm? Okay, so one way is I'm going to pick one character from here, A, and I'm going to check where I'm going to check if I have the character in the second one, and I'm going to remove that character from here, and I'm going to iterate with another character N, and I'm going to check for N. I'm going to remove N. I'm going to go with again A, and I'm going to check A. I'm going to remove the second A, G, R, A, M. Okay, this is a good approach. I mean, this is intuitive, but actually the complexity is very high because we are iterating through one entire string which is of order n, and also the searching could at worst case could be n. So this is an order of n square solution, which is not optimal. So can we decrease the complexity? So one idea is to sort both of them. So what happens if we try and sort them? So if we sort anagram, we get A. So we'll have three A's. So these three A's are going to come to the front. Then we have N, M, N, and probably R, right? Right. And if we also sort this Nagaram, it's gonna also come out as A, A, and M, and R. So can you observe something? If these two are in fact anagrams, then each and every character in this assorted string are gonna match. And if they mismatch, we can say they're not anagrams. But if they do match, then we can say these two are anagrams. So an interesting solution. So let's code this up and see if it works, right? Okay, let me just take it all by myself. Let's take my string A. A is equals to anagram, and my B is equals to Nagram. Okay, now I'm going to sort A. It's a B dot sort, or actually I want to use them as a list. Okay, let's try this and see what we do later. So we're going to sort them, and then for okay, we just have to check for I in range. For I in range, length of A. And also there is actually a very important case that I actually forgot to mention, that if the length of A is different from length of B, then it's very then it's very much given that they are not of same length, so they're not composed of the same characters. So we can just return false, or we can just print false. Yeah, but after sorting, if we check each and every index, like if I say A of I, if it is equal to my B of I, then I'm gonna continue. But if it is not, if it's not equal, but if it's not equal to my B of I, then I'm gonna say I'm gonna break. I'm gonna print false, and I'm gonna break this. Okay. And how can I know that all this happened without any issues? Okay, maybe I can use a flag. No, the flag will be initially -1. So while coming out of it, if my flag is still -1, that means okay, there is nothing has happened. Then I can safely print true. And okay, before breaking, I'm going to initialize my flag to 0. Okay, a flag doesn't it doesn't seem to be able to. So let me say equal. Let's initialize it initially with false. Okay, I'm assuming they're actually true, but if it's not the case, then I'm gonna say equal is false, and I'm gonna check if my equal is still true. If it's still true, then I can say yeah, it's true. It's true that they both are sorted. Let's run this and see. Okay, yeah. So the string object has no method sort. So to sort, we have to convert them into list. So the list is nothing but an array of characters, and so is the string. So this is how Python makes a list of characters. Now I think this should run fine. So it's saying true, but what if I change even one bit of it? Say it's Anagram, then what's my answer? It's saying it's false. Okay, I'm getting false twice. Why? Because okay, I don't have to print false here. I can use this equal, right? I'm just going to use the flag and say if it's equal, I'm going to print true, else I'm going to just print false. And there's actually no way that I can exit from here, so this has to be and B graph. Okay, it's false. So this is one good way, but yeah, we have actually we have succeeded in reducing the complexity from here to n log n, because our sorting takes n log n. So now our new complexity is n log n, which is good, but I don't think it is the optimal one. So can we optimize it more? So instead of sorting, can I use something else? So do we have any idea? So what can we do? Can we use another data structure that will hold the values? See, here we have 3 A's. Okay, then if I have a 3 A's in my other string, so that means okay, I have all my A's covered, right? I have one M here, and if I can have another M in my here, then my case is closed. And similarly, and here are here. Okay, instead of looking at that, I'm going to look at that another way. So I have 3 A's here. So for every A that I'm gonna see, I'm going to increase my count to 3, and for every A that I see in this string, I'm going to decrease my count. So if it is 3 initially after iterating here, then after iterating this array it should be 0. Okay, this seems a good idea because we are iterating them individually, so this is order of n and this again is an order of n. So if this is possible, then this is a very good idea. So while iterating here, I have to make sure that I know that there are actually 3 A's. So A's are 3, and I have one M, I have one N, and I have one R. Great. And now while iterating here, I'm going to decrease this count. So I can see 1 A, okay, I'm going to decrease this. I can see 3, so I'm going to decrease 3, 2, 1, so it's going to 0. I can see an M, I'm going to decrement this. I see an N, so I'm going to decrement this. I see an R, so I'm going to decrement this. So at the end of the day, all my values are zeros. Okay, let us say this is some, okay, so these two are not anagrams. Then I have some other value like Q here. Then what would my list look like? It would look something like, I'll have another value Q. It will be equal to probably -1, and R is still going to be 1. So there is a mismatch. I mean, I don't have values which are exactly 0. So this is not. So these two are not anagrams. Okay. So what is this structure? How can we implement this in Python? So this can be implemented very easily in Python using a data structure called as a dictionary. So this is a dictionary. So these are our keys. So these are our values. So for every key, okay, let's say this is D. So for D of key, I'm going to keep the value. I'm going to increment the value +1 every time while iterating here. And while iterating here, I'm going to get the D of k, and I'm going to decrement the value here. So at the end of the day, I'm going to iterate through my D and see that everything is equal to 0. Then I can say it's an anagram. If it's anything other than 0, then I can say it's not an anagram. Interesting. So let's try and code this up now. Okay, so we have the two strings, anagram, and my B is Nagaram, right? What am I doing? I'm going to use my map, a dictionary. Okay, map is in middle function, right? So let's say my MP is my map. So I'm going to use an empty dictionary initially. Now what am I going to do? I'm going to iterate through my first string for I A. Okay, I'm going to say map of I for an index I. Let us say we got the value A, right? So for the value A, you set, okay, you extract the previous value. You're gonna say D of A +1, right? P of I. If MP of I is already exist, if it exists, then MP of I is just equal to 1. If to, okay, let me write this condition. Let me write the base condition. MP of I, if it is already existing in the map, then fetch MP of I and add 1 to that, Okay, if it's not in the map, I have to first write a condition that I have to make sure that if I in map, if I is an MP, that means I is acting as a key in the map, then I can bring it up. Then I am going to bring it up. But my I is not present in the map, then I have to put the value of I. So I'm going to say MP of I. Initially I found you, so I'm giving you the value 1. If you're already there, then increase your value to 1. So this is what I'm saying. If I'm seeing you, if I'm seeing A for the first time, you're gonna have the value 1. No, you're already there. And then fetch your value and add 1 to that, and fetch your value, add 1 to that, fetch your value, add 1 to that. So that's how I'm going to do that. So now our map is ready. Now I have to decrement the value, right? So for I in B, okay. So if it's true, then I should be present in my map. So I'm gonna say map of MP of I. Okay, let's say if I is in map is in my MP, then fetch the value MP of I is equals to fetch the value MP of I and decrement the value. If it's not in my map, that means the character that I found now is very unique. It's not there in my map. That means these two are not anagrams. But still, as a matter of fact, I have to put it in my map for for the consistency. I have to set map of I is equals to 1. Yeah. Okay. Now instead of printing anything, I would like to just print the map first because it's interesting because I would like to see what happens. Okay, let me print I. Share. Let's see what's there in the map after macro. Okay, it's not a terrible object. I think we did initialize to an empty dictionary. I don't know what's making this. For icon j and empty.values. Okay, it's not values because we need to access the items, not the values. Okay, should work fine now. Okay, so we have a list. So the map has A is 1, N is 1, J is 1, and R is 1, N is 1. But this is not what I'm looking for. I'm looking for values to be negative 1. But okay, find the if it's not already in B, I don't have to add it. That is what's making it. Okay, I don't have to add it. I'm just going to decrement that. Okay, so this is something what I had expected, but why is n minus 2? Okay, so I think this actually works, but we need to add some more functionality. We should make sure that the map is fine. And also instead of map, I think probably we can use some other data structure. Right? I'm getting ideas. So why don't we use an array of size 26 and use the ASCII values to store them? Hmm, probably that's a good idea, but still I'm gonna go with the map, right? So let's see. Okay, so we're going through the items. Okay, it's fine. Mm, let's see, this is the tick. So yeah, I think we can use. Okay, instead of going for this, I can write if my char is okay, if for I in S, I can say uh, my map of I can be my map dot get. Okay, get me the value of I, and if it's not present, then initialize that to 0, right? I want you to initialize that to 0. If it's not there, then initialize that to 0. And since you already have it, you're gonna need to add 1 to that, right? So this would make sense. And I'm gonna do the same for this as well. And np.get get the value of I, and if it's not present, let's put a 0 for that. And if it is present, then let's say -1 for that. Let's run this and see what we get. Okay, now I think now it's working fine. Okay. Let's give some other anagram like rat and art. Okay, let's see what it is. So this is exactly what I'm expecting. So now how can we say? So now instead of printing